Welcome back. So, this is a site I've been working on and off now for a couple of years. So, what it is this site is a normal house, and it started off as a grid feed-in tariff system. Okay, so that would have been a couple of years ago, and I'm very happy with it. Everything was fine. And what they wanted to do is, I mean, that's obviously now a system that's knocking on to 5 years plus old. So, and that's installed, and that's just a traditional, probably about 3.5 kilowatts of solar inverter, and then feed-in tariff, and all the rest of it. So, what they wanted to do, however, is use that energy more in a useful way, and bottle it and use it in your own batteries, and then use it whenever you want on demand, not when the sun comes out and everybody's out the house, and then that's the ideal time to run around turning on your dishwasher and washing machine, everything else. So made the kind of leap and went for battery storage and have it in a situation where they're effectively off grid. But for the purpose of this is also still grid connected. So this is a cheaper alternative and setup to the SMA setup. So to give you an idea, so each one of those big inverters up there we go, is 5 kilowatts each. They're Voltacons. It's the same branding. PIP, MPP inverters, they all go by different names. So, but Voltacon is actually the genuine one. Again, like all good copies, they also come out now and make copies of those, and they're not as superior. I'm not going to say they don't work, but they're not as superior, put it that way, especially for longevity from what I understand. So, this is really now, and in this system's been running for a couple of years, and the reason why we're here is what started off as, and there you go. So now you can understand why we have half a BMW i3 pack, is because the other BMW pack is up there. So that's what originally went in up there, and that was 10 kilowatts of storage. So and you can wall mount them. As you can see up there, there's some nice mounting points on the BMW packs. So if you remember what I said, they are short, effectively, on what you want to run by 2 cells at the end. So originally we had these on, I think it's 12 cells, 14 cells, 12 cells. So I think there are 12 cells each BMW pack, and then we had some 18650s wired to increase the capacity. But the same thing as like we had at our system, which was you end up with drift, because the 18650s are a slightly different chemical. So even though they have the capacity, they work at a different voltage range. So it can be done, but it's not the best overall solution. So what we've got now, right at the very end, is there you go, 4 Nissan Leaf cells. And they're wired in parallel, but if you imagine 1 Nissan Leaf is the equivalent of 2 cells. Okay, so that gives you an idea. So so that's 2 in series added on. So I'm pretty sure it's 12, the BMWs. So that would now make it 14 series, right? And nothing really exotic. Originally we had them running on BMSs individually, that's why you still got all the original BMS cables, but they're really only there for balancing. So nothing major there. Copper bus bar at the top, you just make them. Nothing amazing. Again, copper bus bar on the neutral, just add a bit of protection. That runs full length, gives you somewhere nice and tidy. And then we had the original shunt up there at the top, and so things that we have added, Victron shunt there, smart shunts, they're great, really accurate, well worth it. I think you get them for roughly around about £100, something like that, give and take. But really, really good. They've got Bluetooth connectivity and they can integrate directly with Home Assistant. So, pretty much stuff you've seen before. So, excuse the wiring because we're still not finished yet, so it still needs tidying up a bit. So, you still got the original Nissan Leaf, Panasonic contact relay, DC. So just to tell you as well, so they definitely run 12 volts. So don't think about connecting that up to your system and going in and out of a relay. It'll just melt them after they've been powered up for too long. And you can just about see in there's the resistor, which you need to then jump across when the contactor's off to prime your system. Or otherwise you will have a huge inrush into your inverters. So that is, I would say, especially on systems like this, is to think about doing something like that. Don't. Okay, you could start it up. You could fiddle about with a resistor, bridging it, and this, that, and the other. It just takes another level of pissing about out of the situation. Again, you can see there's 2 fuses, 1 for each. So if you do have a system failure, the good news is you can always isolate it, or one or the other. Yes, you'll be down on capacity, but you still have lights on and everything's still running. Other things, if you're doing solar, and bear in mind, I mean, one of these only, still at the moment, we've only got 1 set of solar panels connected. Okay, so this one actually isn't running with any solar. So this is what's happening now. We're taking off the feed-in tariff grid feed system solar, and we're going to be pulling that string into here, and this string is running with solar, but both of them still feed in the batteries. Okay, so I would say it gets 95% of what you want to achieve with SMA equipment, but at a fraction of the SMA cost. Okay, that's the best way I can describe it. So, and then with the Storm units, we actually had 1 wind turbine installed here, and it just crashed it out and blew it to pieces. So, actually, it didn't blow it to pieces. The guide wires basically gave out, and it bent over the scaffold tube here. So another turbine has now got in place, and we're running now the smaller ones here. So we were running like the Thermodyne type, and now we're just running one of the smaller ones, and we're having better results. So if I just go through the wind turbine part, nothing exciting. So this is like one of those piece fair meters. These are great. They'll only fire up. I mean, you can see there's next to no wind there. That'll be moving at hardly anything at the moment. And these are great they just run in the background, collect the data. So if you're the kind of person that just wants to know working, not working, and just keep everything very analog, then this is one of the better way to go. It will log it, you can reset it. There's not really too much functionality, and the way that we've wired it with blocking diodes, it'll only power up as and when there's actually voltage being produced. If there isn't any volts, it won't produce anything. And again, as I said, we've only just installed this one. It's only got it up and running a few days ago, but we've had no wind, so production is nil. And so what you get with those little cheapy wind turbines that work very well, I can't knock them, is you also get a wind controller of sorts. Okay, they're not great, they're not the worst, but they're something, put it that way. So they're good for, they basically, if I remember rightly, the braking voltage is about 60 volts, the reconnection voltage is about 54. The controller is waterproof, but you can either use them if you want to, just purely as dump loading for the wind turbines, or if your battery's getting too full. It's some sort of protection, better than no protection, put it that way. And they also have the bridge rectifier built in. So you've got your same 1, 2, 3 phases of wild AC that comes out of the turbine. So that's up here, 1, 2, 3, goes into there, which is a bridge rectifier, comes out now, so it converts the AC 3-phase wire from AC to then DC, comes into DC, through a DC breaker, out, up, and then connects up there in those terminals, and then goes back down to the batteries. Okay, so nothing really exciting there, and that kind of all comes with it anyway, the controller, so nothing too much to worry about. Again, keep your boxes separate, DC, AC, so don't mix them, don't match them if you don't need to. What else? Little shunt meter there. Pretty good. Again, it's what was installed here, just so that people can, as they're wandering past, just double check, is that the correct watts, correct amps, and more of the point percentage. A little button on the side, and that's used for the priming circuit. So as I said, through your resistor, it'd be about there, resistor, and then it goes up to the contactor. So when you prime the system, you're just holding down that prime button, which is just a make or break here, for like say 10 seconds. You don't really need it any more than that. It's just so you don't have a huge inrush. It's like 40 watts, 50 watts resistor, just to get the circuits, get the capacitors and everything charged up in the inverter, so you don't have a massive wallop going in. Okay, so that explains DC side. Fairly simple. Nothing really exotic to piss about, and just make sure you buy like DC breakers. Don't be tempted to go and use AC breakers. They just don't work in the same way. Okay, it's as simple as that. And if you can, you just buy colored cable. It's just going to make your life easier. Yeah, you could run everything in one color, but yeah, fault finding later, a pain in the arse. So AC box side, so the way that we've done this is slightly different. So you can see the two big mains in, mains out, right? So mains in is obviously coming from the mains grid. So starting from the right, yeah, it's going to be easier. So that's your mains in, as in from the grid connection. What we've also done is put a two-way changeover switch. So if the mains ever fails, you can then flip it over, and we've put a generator connection on there, but there's no generator here. It's just if you need one, it can be done that way. For some reason, if the mains grid fails for 2, 3, 4 days, whatever, at least there is the option there. Breaker for the inverter, next one's water heater, next one's control circuit. That's just to run plugs, etc. in here. And then more importantly is the mains out from your inverters. Okay, so you can turn all the power off is on the mains going in. It won't make so it won't make any difference whatsoever. There you go. Yeah, there you go. See, so that's effectively now on a generator connection, which there is no generator, and everything's still powered up. We're not worried. And then flick it back to mains in again. And if you want to do the same thing, you could isolate it and then clip everything down from the inverters coming out. So you do need to make sure you've got two lots of isolation there. One on your main grid feed in, yeah, and also one on the out, okay? And then these are just for your individual inverters. So if there is a problem with the inverter itself, you could disconnect it from the AC, okay? That would be AC in, from your grid to the inverter. Then what you could do, you disconnect it from the battery, just pull the fuse, okay? And then also disconnecting it from the solar if it is connected to the solar. Yep, okay, so that would then isolate if you need to do just 1 or 2 or whatever you need to do. So when we first started this, so that would be 10 kilowatts of inverter, and what was that? Roughly, let's say 10 kilowatt hours of battery storage. And it's one of those misconceptions, people getting the confusion between kilowatts and kilowatt hours mixed up. So what you find is a lot of the time the mismatch between the two usually happens because the batteries are sized incorrectly. So what we mean is you can't, you might have 10 kilowatt inverters because by the time you've got your kettle and your cooker and this, that and the other, you turn all those on, yeah, you're drawing 10 kilowatts of power. Your batteries, however, you've decided that you only need 10 kilowatt hours of battery storage per day. Yeah, that's true. However, trying to then pull 10 kilowatts out of something like that is, yeah, it's a lot of amperage, and sometimes it's more than what they can sustain. So even here, we knew that long term we needed more storage, not necessarily for the storage itself, but what you want to do is pull out a whopping great amperage in the moment, in one time. You want to go around, you want to turn your kettle on, your cooker and everything on all in one hit at night. And so that's when we looked at it and said, right, you need larger storage because it happens but once in a blue moon. Okay. So eventually there's going to be about 7.5, 8 kilowatts of solar going into those inverters. They're then going to start charging the batteries. So we wanted to do two things. One is get rid of the feed-in tariff and use our own solar, then bottle it as well. But there's no point if they're going to be full, right? So what we ended up doing, get hold of another Nissan Leaf pack, right, and break the pack down, and then build something like this. Okay, so it's all plexiglass. So a lot of people are going to go, oh, don't put your batteries here, there, and everywhere. Okay, look, you can only piss with the dick that you got. So in this case, it is being installed inside. I'm not massively happy, but maybe it's something that will retrofit or go outside later. But for all intents and purposes, it's safe. Safe being it has a BMS, safe being it has shutdown procedures, safe being everything is done correctly with the right size amperage cable and bus bars, etc. So, and fused obviously. So what we've actually done is attach from the connection points up there again, pull them all the way back down on new cabling. You got a fuse there somewhere. Okay, so it's similar kind of setup again. It just takes some time and just carefully just plan your way on how you're going to set your batteries up. So we wanted to reduce the size of the footprint as much as possible, but not be too heavy. So something like this is going to be weighing in at what, 260, 300 kilos maybe. So it's a lot of weight. So just make sure whatever you're putting it on is something quite substantial. Okay, and then you can kind of see these are all aluminium. There's some bits you get, so you can see the copper bars. You get them inside the Nissan Leaf, and these individual ones you get also inside the Nissan Leaf. The individual ones don't really matter. You could use thin 2 mil, 1 mil, 1.5 mil probably cable. This is only for the balancing, but you just want to make sure that it's going to balance all the cells at the same time. But you know, they fit and they come free, so why not use them? Aluminium, however, as buzz bars. So I've always been a little bit more, I'd like to use copper, but the price of copper at the moment is just ridiculous. So, I mean, there is calculations out there, especially online calculations. If I remember rightly, I think the ratio is basically you need it upscale by about a third. But don't hold me to that. It's either a third or it's 3 times. I can't remember which one. So to do the same kind of amperage pull, so you know, this and the size of the cabling and all the rest of it and the buzz bars, it's all designed for around about 120 amps, something like that. So that's 120 amps in and out, plus obviously then up there as well you've got almost virtually the same. So you know, you could pull a ridiculous amount of amperage through the cabling and the buzz bars and everything and be quite safe. But if you are going to go down this route, the savings are, you know, on something like this, you would spend about probably £150, £200 on copper to do the buzz bars when you could spend, you know, £40 worth and do it in aluminium. So if you are building your own battery packs, then Look at that for bus barring. It is a far cheaper alternative. Just get your sizing correct, and as I said, go and look online and find some of those calculations to work out what it can do, basically, and you'll find it will be no problem. But just give you an idea how it's mounted, and then you just pre-drill each one. Don't sit there on the Nissan Leaf, because you can see from here the packs are different sizes as well in height. So it looks like I've sat there with a pillar drill and drilled each one, right? But I haven't. I've had to literally mock it and then mark it up and then drill each one individually, which is a pain in the arse, but the outcome is very, very nice. And this is what it's all about. I mean, it's nice having batteries, and engineering is all about, if something to a degree looks right, when it's finished, it usually is right. So I don't want to revisit this. You think I want to take this cabinet apart? Definitely not. After it's all been built, and then we just threw a little thermometer in there, just keep an eye, nothing major. Again, similar thing. Why don't people put a light in the batteries? The reason why is, what happens if you have one cell that goes bad, right? Not bad enough to trip your system, but it goes bad. So this way, even at night, you just have a quick look, and you could see straight away if one of the batteries is swollen. It's signs of failure. So you'd be able to pick that up straight away. So having, a little epoxy, I don't know what that is, probably SMD lighting on USB, it's like 2 watts or something, just sacrificing. You can have a bit of lighting, turn it on and off if you want. Right, so control-wise, let's go on to the more interesting kind of bits. So, all right, let's get that out of the way for a start. Okay, so there's going to be a bit of a distance. Sorry about this, guys. So what you've got is 12-volt transformer, effectively. So it's, I think 60, 70 volts, something around that, or it'll do like 50, no, probably less than that, 45 maybe volts to 65 volts DC, and then it'll convert it down to 12 volts DC. Now you need that because you want to run up there your 12 volt contact relay, right? That came out of the Nissan Leaf, so you need 12 volts. You need 12 volts if you're running fans, if you want to use 12 volts. So there is quite a few reasons why you need that 12 volt, and 12 volt equipment at least is a bit of a go-to. Make sure when you get that as well, this one I think is good for about 300 watts, so if I remember rightly. So just make sure you buy one that can do the wattage and go over the top. I mean, yes, we've got a couple of fans and one contactor here. That's not going to take anywhere near 300 watts, but you want this to be in service for the next however long. So, at least then this way for definite that you've not overloaded it. Don't get one that's just 60 watts or 70 watts and then find out that it burns out after a year and a half, yeah? Because if that burns out, that one, then you will lose the contactor and your fans and this, that, and the other. The whole system will just shut down. So just buy one that's a little bit over the top. Terminal relays, nothing interesting there. Then you've got a DC contactor right at the end over there. Okay. So, similar thing again, that's all your BMS wiring. So, that's all the ones from the top down into the same terminals and all the ones at the bottom. So what we're doing is taking each BMS wire, okay, the little ones, yeah, and connecting them, let's go back up, to the BMS wiring up here, okay, and then each one then goes together through the terminal block. So you can see down there, yeah, so say cell 1, where are we, cell 1 up here, and then it'll be connected cell 1, cell 1, cell 1, and then down there also cell 1. So they'll all be joined together into eventually one terminal block, which is down there, and then from that terminal block it goes round and then goes into the BMS, which is that REC BMS, to do balancing. So you can see I've modified this REC BMS. We've tried all different ways, tried heat sinks and this, that, and the other. It just gets too hot when trying to balance. It's as simple as that. and then it will trip out because it will say that the BMS is too hot. It won't trip the system, but it will stop it from balancing. So the fan there will just cool it just enough to stay doing what it's doing without damaging anything. Yeah, so it is something you want to think about, but you have to literally take the unit apart, drill it out, so you got fresh air in, and then it comes out the bottom holes out, and hopefully we'll see how that goes over the year. If not, then we'll have to come up with something else. It's that simple. And then that's your software for the REC. Pretty basic, but it does what it's meant to do. So you can see at the moment cells 14, 13, 12, 11 are low in comparisons to the rest of the pack, and that's the batteries that we added to the BMW. So that is now at the moment is actively balancing. So doing some mileage. So that's the there we go, active balancer working there. It's only a little 1 amp, but that'll be enough just to over time balance those little packs out, and then it will just be left on, but in redundancy. Could turn it off, wouldn't make any difference. So that basically explains, that end. There's nothing really much more you could do on that. That's pretty much it. So the REC BMSs, so you see those 2 terminals down there. So that will go through like a solid state relay, an optocoupler. So that's the input outputs that you want for your relay contactor up at the top, up there. And you can either just drive it through the negative or the positive. Really makes no difference once you stepped it down to 12 volts. Because as I said, the amperage is so small, just to drive that little or that big contactor. That's not really handling anything, and it's quite safe. So, but again, you can always just use little 5 amp fuses and 3 amp fuses and things like that, just to make sure it's also, again, doubly safe. You don't want to blow your BMS, and basically do it that way. So that hopefully gives you an idea of, then you use like the REC BMS, which the system can't see because these inverters can't talk with that REC BMS, but it will still be able to do what it needs to do in the background, and the inverters know no different. So the safety aspect is still there. If there's any problem, any cell too high, any cell too low, it will still drop the contactor. The only downside is because this can't talk with the inverters, the problem is your charging curve, it hasn't really got a taper. It tapers internally, because effectively they're set up for custom batteries, or in this case it's a modified lead acid charging algorithm almost, right? So what you have to bear it in mind, it might whack the juice in until it gets to a certain voltage, then slowly taper off and ramp down, right? So long your battery bank is large enough, I mean, this is going to be knocking now, what's that, that's 24 kilowatts, let's call it more like 20, so plus up there, that's 30 kilowatt hours of battery. I mean, they'll take no problem charging at 200 and something over amps, yeah? So for us, you just have to go in and set these to charge at no more than whatever it is. So in this case, we're not having them charge any more than 100 amp at a time. So, excuse me. So I know that the batteries will be safe even as they get towards the top. It's not going to be charging at 100 amps when these are almost full, okay? I think that's really the best way to set it up. So you can run this kind of equipment, except you do need to know ins and outs on the batteries, especially because it becomes a bit retarded. It can't really see what's going on with the batteries, nor does it really care. It'll just keep whacking the juice in. So it's either that or you go down the other route. This pack we got a Nissan Leaf pack for, I think it was like 1,500 quid, right? So plus the BMS, you're talking less than a couple of grand, right? To get that, which would be 24 kilowatt hours, right? So if you went down the other route and you wanted it to communicate with the batteries, so you want these two talking to lithium batteries, then you would have to go for, say, something like the cheapest route would be Pylon Tech. And they have BMS built in that will talk with those inverters. Yeah, but then the price, I can guarantee you, is going to be way more than that for the same kind of kilowatt hours. So, I mean, that will give you an idea. So, again, you can do your BMS, you can do your own home brew of batteries. Just, you need to think to yourself, do you feel comfortable doing your own wiring, your own layout, your own this and that? And really, it comes down to just take your time. There's no rush. If you take your time, and most of the problems fall apart because of that. So, but it's fairly simple. There's nothing really here that I can say is, these are specialised knowledge and equipment. Okay, right. So yeah, battery crimp. You want a hydraulic one? Well, yeah, like £30 on eBay. So what the hell? Here, heat shrink. Well, not a problem. Ring terminal crimps. Make sure you buy decent crimper, decent crimps. Make sure you buy plenty of them. Cabling. Make sure you buy plenty of it, and take your time. People want to rush these things and get the whole system up and running within 12 hours for some ungodly reason. Just take your time, cut your buzz bars down, just order it as a big long length, and then just cut them down. There's nothing special or secret juju black boxing. Just and so anyway, that explains all of that side. So. More importantly, because a lot of people have said, yeah, but they don't harvest the data. Yeah, data, bricks to build a building. So, up there. Okay, so up there we got a Raspberry Pi 3B Plus, right? And all of that is doing is running something called Solar Assistant. So I've talked about Solar Assistant before. Again, nothing particularly special going on there. So, there you go. That's Solar Assistant. That's the system that's running here live now. Okay. Pretty straightforward. Nothing amazing. Okay. So, however, what we are running is also Home Assistant here. So that's something new that we're also running. Again, and very old, elderly. Acer Revo, there you go, Acer Aspire Revo R3700. Only thing we've done is put 4 gig of RAM and a solid state drive in it, an SSD. Okay, but I mean, you're not talking about the earth. You don't need a massive anything. You don't need a massive hard drive and a massive this. It just sits there doing very little. So again, what you do is you install, go down, download it for free, Debian or Debian 11.0. Once you've got Debian 11.0, which is a Linux operating system, but thankfully it's not lines of code. You do get a nice graphic user interface. So once you've got that up and running, then you have you can then lay on top of that then Home Assistant, which is how we are running it. So you then get the functionality of having a Linux-based operating system, which you will need. A lot of the stuff that you want it to talk with other things and have sensors and this, that, and the other, it needs that to be in place. Having all the jungle juice in the world that you're manufacturing from outside, the sun and the wind, well, that's great. How are you going to use it? Where is it going to? That's the problem. People want to have all of this. Oh, look at my system. I'm doing 50, 100, 50 megawatt. Yeah, okay, right. And how are you going to use it? Oh, I don't know. Right, so you're just going to run around like a lunatic now, turning all your plugs on and off. Right. Well, no, that's not the way forward. So, yeah, cheap as chips, like £35 or something. Yeah, whack Debian 11 on it. Have your operating system, put Home Assistant on it, and you're done. This is a fairly small system, actually. There's not really that much automation or controls. So, I mean, theoretically, we could have just used a Raspberry Pi and then done it that way. Yeah. So, but why have one system when you can have a second as a backup? So, hence the reason why that Raspberry Pi and all it does is run that solar system, which for most people they'll go, oh, it's great, it's perfect, does everything I want. Doesn't do any forms of automation though. That's the only problem. So that's what really that one's being used for, is to run a Home Assistant. But theoretically, you could just run Home Assistant only, and that would do the job of Solar Assistant as well. But you know, why have one when you can have two? So yeah, and then you can kind of get an idea of what's running on Home Assistant. There you go. Production's not great today. And again, things like Home Assistant, the best bit is you have things like forecasting. So useful. So you can actually decide whether it's going to be an absolutely crap day or not. You know, and then once you've got that, because everything is AC coupled after that, so you don't need to piss about changing your water element, and I need a DC 48 volt and crap like that. Yeah, you don't need to do all of that. You can just go straight forward and have your standard AC one in there and have it triggered from your thing, okay, from your Home Assistant.